Greetings for the day to all. This is a very brief presentation on PilotSite selection, satellite data needs, leveraging the key resources by the participation of users and stakeholders for addressing the C2 land project. The broader goal is, however, to study the impact of cyclone on coastal water level and inundation, but my briefing is particularly on the choice of the pilot site. Located in the tropics, Bay of Bengal is the largest bay in the world and is bordered by India, Bangladesh, and Myanmar. This basin is very different from other parts of the oceans in the sense that nearly a dozen rivers that include Ganges, Brahmaputra, Mahanadi, Godavari, and Meghna, they feed into this bay. As a consequence, this region is fresh and warm at and near the surface. As a result of this stratification, the upper layer of the ocean contains a lot of heat that fuels the cyclones, and many of them have been in the category of extremely severe cyclones. These storms results in high water level, extreme wave conditions, and large-scale inundation, flooding, leading to large-scale damage. These storms and associated oceanic conditions impacts the sediment loading and affects the biogeochemistry of this region. Let us see the cyclone hazard analysis map, which is shown here. In this figure, you will see that cyclone hazard prone regions have been identified based on the frequency and intensity of the cyclonic winds. These different codes, basically they represent the degree of proneness. As you can see from the marked region in the black ellipse, exhibits high degree of proneness, suggesting that these regions are extremely vulnerable to the cyclonic impacts. Hence, it is one of the most suitable sites for addressing the coastal issues affecting a large population residing in the coastal regions. An example of how we make use of the satellite imageries for cyclone track monitoring and hydrodynamic modeling for surge predictions are also shown here. Next comes the kind of satellite data or the parameters which are required to carry out the impact and damage assessment activity. These parameters are listed here. Out of them, bathymetry and digital elevation models are the two most important layers which help in modeling the surge and therein assessing the extent of the damage. Hence, bathymetry estimation from satellites, making use of both the optical and the synthetic aperture radar data, is one of the central activity under C2 land theme. So in the several post meetings that we participated, we deliberated on satellite data sets for bathymetry estimation, accuracy of the estimated bathymetry from the satellites, availability of the analysis ready data, requirement in terms of resolution, corrections, portability, format, etc. And most importantly, we discussed how the validation data is going to help us in validating the satellite-derived bathymetry. Next, you can always question, what are we going to offer to our partners, be it users and the stakeholders, if they work with the coast team. So apart from sharing the in-situ data for the validation, we are looking to engage with them and offer them the product that they can make use in the decision support system and policy making. So we hope and we are quite confident that the product, in this case, the bathymetry that we are going to demonstrate, will definitely enthuse the users and will be a great contribution from the coast team towards United Nations Decade of Ocean celebration. You will hear more on the product from my colleague, Ratish Ramakrishnan. Thank you and wishing you all a very fruitful and engaging meeting. Thank you.